Hello, what's going on? Last question for the sack. Last question. All right, I'm so excited. Why? It's a reaction pathways. Everyone loves reaction pathways. Do you love reaction pathway? I love reaction pathway. Okay, because why? In order to do a reaction pathway question, you need to know all the organic reaction we've discussed. All right. Without further ado, let's get into this. All right, question three. What are we trying to do? Well, look at this. By just looking at this question, I know exactly what they are trying to do. Look, we are going to get the carboxylic acid. We are going to get a what? We are going to get a carboxylic acid here. Yes. What? Propanoic acid. We are getting propanoic acid. Then it seems like we are using the propanoic acid somewhere here. Oh, you know that. What? You know that acid and oh well, alcohol. Look at that. This it has to be a ester. In most cases, they are trying to make esters. Okay, but nowadays nowadays we can know students are so used to make esters, so they give you sometimes secondary amide. All right, but we will look into those questions later. Don't stress. We start doing this first. Okay, are you ready? Are you ready? Okay, let's get on to this. Okay, now here, what are we doing? You having a this is a butte. No, it's not butte. No, it's prop, man. This is propene. You got propene here. Then you're adding HCl. You know that in this case, it's the carbon-carbon double bond is located. Oh, I was meant to say it is not symmetrical. So you can end up getting two products. Now, yes, they are even given you two boxes so that you can write those what those products are. You can write what those products are. Now, in doing so, what you need to do? Okay, just do that like so. Then you're adding HCl. Chlorine can go to the middle carbon or chlorine can go to the last carbon. Is that clear? Okay, in this way you can get two chloropropane or one chloropropane. Simple. Then what are we trying to do here? You are going to make propan 1-ol. So we have to use one chloropropane. One chloropropane. The X has to be a substitution reaction where X has to be sodium hydroxide. So chloroalkanes. Chloroalkanes undergo substitution reaction. You know that, right? So since we are trying to make one propan 1-ol or one propanol, you need to use the isomer B. We have to use the isomer B. Okay. Then you get the primary alcohol. Propan 1-ol is a primary alcohol. Why it's a primary alcohol? You see that hydroxyl carbon has got one R group or two hydrogen. So that's a primary alcohol. Primary alcohol can be oxidized into carboxylic acid with the presence of acidified potassium permanganate. I mean, primary alcohol, carboxylic acid, you know that it is acidified potassium permanganate or potassium dichromate also works, but dichromate, this is dichromate ion, right? If you want to write the full compound, which is potassium dichromate, K2Cr2O7. Now, do not write K2Cr2O7 minus 2, that's wrong, or KMnO4 minus 1, that is wrong. Your teachers will hate that, okay? Okay, we got the, and you have to add heat, yes? Do we have to add heat? Yes, not the mild condition. Mild conditions will give you aldehyde. We don't want aldehyde because we know that aldehyde will not give us the ester. We need to have the carboxylic acid. Haha. All right. So we get the carboxylic acid. Okay. Then, oh, that's done, man. Okay. Then what do we need? We need the alcohol. So what's the alcohol we need to make? We need to make with this one. Only alcohol you can make is chlorine. Oh, simple, simple. What's that? So one chloroethane. This is one chloroethane. Oh, what's that? One chloroethane and byproduct is HCl. Oh no no, no! It has to be the other way around because C has to be the HCl. C has to be the HCl. D has to be the one chloroethane. Yeah, one chloroethane, isn't it? Is that clear to you? Huh? All right. You see that? Then you add sodium hydroxide. Then you get what? Ah, you get the ethanol, man. We want ethanol because it's a substitution reaction. You know that. Both the oh, sorry about that. Sorry about that. I have to go back because I haven't had. Okay, let me go back. So we got one chloroethane. So let me do that again because wasn't had the camera on. So then you're adding a sodium hydroxide, which will make a what? Which will make yeah, look at that. All right, OH, ethanol. So ethanol and ethanoic acid is a Z has to be concentrated sulfuric acid, right? Without that, the reaction will not simply happen. So you are going to get what? Ester and water. The condensation reaction. What is the ester? Draw the ester functional group. Then this is the lonely oxygen, drink alone. So that is ethanol. This time they can drink ethanol. Okay. So 2 carbon. Yes, yes. You got 2 carbon here. Is that right? 2 carbon goes there. Then you get a propanoic acid. That's done. Okay. That's propanoic acid. That no, the propanoic the acid, propyl part. Sorry, a propanoate part. So what is the name of this ester? Ethyl propanoate, right? Okay, we got it done. Okay, that's easy. All right, not too bad. Okay, B, using the propene as one of your initial reactant, draw the reaction pathway need to produce propan 2-amine. Wow. Okay, that seems like a bit of a different question. They're asking us to take propene. Propan 2-amine. Okay, so that's not that difficult. Always what? Always start with the. No, it's better to. Why do I do the structural formula, not the semi-structural formula? Well, you can end up making mistake with the semi-structural formula. You don't see the atoms properly. Yeah. Now, in order to make amine, what you need to do, you need to add NH2 group. Okay, it has to be a substitution reaction where we are going to add NH2 group. So what do you think? What can be substituted by NH2 so that in ammonia, we need to have ammonia. So ammonia has got the NH2 group. We are going to plug the NH2 group in. We have to take something out, which is halogen. We kick the halogen out, man. Kick the halogen out. All right. So in this case, we need to make it to a chloroalkane or chloro. Oh, what is happened, man? Chloroalkane or a chloro bromine, yeah. So in this case, no, not stupid chlorobromine, bromoalkane. So in this case, what we can do, we are adding HCl, but for propan 2-amine, remember the amino group, amino functional group has to be the second carbon. So you have to be careful with that. In other words, we need the HCl chlorine into the second carbon, then we can kick it out and plug the NH2 group in. That is our plan. All right, so we do this here. We go. All right, now we got our chlorine ready. Chlorine is saying, what is chlorine is saying? Hey, hey, get me kicked out. Get me kicked out. Ammonia is saying, ammonia, here comes amine. I'm going to put the NH2 in. I'm going to kick chlorine. I'm going to kick you out. All right, take it easy. All right, then we are going to take ammonia. Look at that substitution reaction. Previous one is addition reaction. This is addition. Alkene undergo addition reaction only. We know that. There is no byproduct. When there is addition reaction, there is no byproduct. So number one, that there is no byproduct. Okay. Then what we are going to do, we are planning to get the chlorine out, kicked out by the, that's a substitution. Every substitution reaction will have a byproduct. Now, what's the byproduct of that? Ammonia has got H and Cl, HCl. Oh, that's done. Okay, that's done. Show the formation of the secondary amide. Oh, there's another one. So that's done. Reaction and products involved. Okay, we've done that. Okay, let's go to the last part. Okay, I like that because they want us to make amide. Secondary amide. Do you know what secondary amide is? Okay. This is the amide functional group, right? Amide. This is the amide functional group, C double bond O N. Okay. If you want to make a primary amide, look at that. The N has to have two hydrogen. If you want to make a secondary amide, look at it as N has to only have one hydrogen, so this had to be another carbon. So they're asking us to do a secondary amide with what? I don't know. I haven't propanoic acid and ethylamine. Secondary amide. Yeah, it's a secondary amide. Yeah, it's going to be a secondary amide. That's not that difficult. Get the propanoic acid. You know, that's a carboxylic acid, which is called a propanoic acid. All right, it's like, carboxyl functional group. Oh, yes, we know the propanoic acid. Now, ethylamine. Oh, ethylamine. Ethyl means two carbons. Amine means NH2 group. Look, I have got the business ends facing next to each other. Because why? Why? What happens when the business ends are facing next to each other? A business happens. What sort of a business is going to happen here? A condensation business. We know that. We know that. All right. So ethylamine. Yeah. We draw that. All right. So we have done that. Here. All right. Now we are ready, man, to do the condensation part. The business is going to business is about to happen. All right. H is going to go away. H is going to get. Oh, the water is going to come out. Now we are making the secondary amide. Look at that. You see that? You see that? Oh, all right. Secondary amide. Oh, so this is the carbon part of that. Yeah. What else are you going to form? What else are you going to form? Wake up, H2O. Why? I don't get any answers from you. Come on. I need answers, man. So this is the secondary amide of the peptide functional group. Yeah? All right. We did 2 sacks. I'm planning to do another one. See you soon. Bye-bye.